Let's have a look at some movable pulleys. Of course, it won't move now. When we're talking about a movable pulley, the situation we're talking about is that we have this cylindrical mass here connected to a solid mass here via an immovable pulley. So this pulley isn't moving, but this one here is. And what can we say about that? Well, the first thing we can say about that is that the tension on each part of the string here, here, and here is going to be the same because it's the same string. Then, if we look at the mass Q, we can say that the mass Q is going to have a downward force of the mass of Q multiplied by G and an upward force of T. On the pulley on the left, the movable pulley, we can see that the upward force is going to be divided between the two strings. So that means that the forces on P are going to be downward, the mass of P multiplied by G, and upwards T plus T. So there are forces. Now we know that to solve any problem we need to resolve our forces and we need to know our direction of motion. So we need to look at the direction of motion, and how are we going to do that? So normally we look and see which one has the greater weight and work out from that. But that's not necessarily going to happen here because this one could have a greater weight than this one. However, that weight is going to be distributed between these two. So that means that the pull on these two could be less than the pull on this. So we have to see how the pull is distributed between these two or these three areas of the string. Okay, and see which one's heavier. So we're looking at the tension here. And we can see that here on the two strings on the left, we can see that the tension is divided between two. And on the string on the right, that gets all the upward force here. So basically what we're saying is that if the downward force, or if the pull here is greater than the pull here or the pull here, well then it's going to go down. The acceleration or the direction of motion will be down. So we have to look for that. So how do we do it? Is you will work out the weight of this pulley P, the movable pulley, and because it's divided between two strings, you'll divide it in two. And if that number is less than the weight of Q, the motion will be down. If this number is greater than Q, well then the motion will be in that direction. Okay, so you compare them two numbers and the direction of motion will be towards the larger number. So if it's here, which it usually will be, what you'll find is that this is going down, up and down, and that's the direction of motion. Okay, and they would actually be considered to be going up together, and this one's going down. So they're going up and that's going down. So because they're working together. So now we have to look at the magnitude of the motion. How are we going to work out the magnitude of motion? So let's have a look and decide here if the mass P, if that mass P moves up by 8 centimeters. So if that goes up by 8 centimeters, that string is going to shorten by 8 centimeters. This string is going to shorten by 8 centimeters. So that means there would be 2 centimeters available to lengthen this string. So the mass Q will actually lower by 2A. So whatever this goes up by, this goes down by twice that. So what does that tell us about the magnitude of motion? Well, it tells us that the mass Q moves twice the distance that the mass P will move. And this will actually transfer to velocity and acceleration. So the acceleration of P, whatever the acceleration of P, if that's going up 1, then the acceleration of Q is 2A. So if P is the acceleration of P is up 1a, the acceleration of Q is down 2a. So let's look at this example. We have a light and extensible string fastened at one end to a point on the ceiling. It passes under a smoothable, movable pulley of P of mass 8 kilometers and then over a smooth light fixed pulley. A second particle Q of mass 6 kilograms hangs freely from the other end of the string, and all parts of the string which are not in contact with the pulleys are vertical. Find the acceleration of the 8 kilogram mass. Okay, so remember, this is the situation that we were just looking at in the last slide. So the force is on this pulley here, on P. We have 8G going down, so it has a mass of 8 kilograms, so the downward force is 8G. The tension up here, okay, on each string here is going to be 4G on each of these. On this mass here, which is 6 kilograms, it's going to have a downward force of 6G and an upward force of 6G. So which of these is going to have the motion? Which of these is this one going to be going down, or is this one going to be going down? This is 4G, this is 6G. 6G is greater than 4G, so this one is the direction of motion. So if that's going down, that one's going up. So now we have to look at the magnitude of motion. So again, here, there are two strings pulling this one up. There's only one string holding this one up. So if the acceleration of this is 1, the acceleration of this is going to be 2. Because remember, for every 1 centimeter this goes up, this will go down 2 centimeters. Okay. So the situation we actually have is that you have the mass of P with 8G going down and the acceleration going up. Then the mass, the 6 kilogram mass is going down with an acceleration of 2a. So to find the acceleration, we're just going to look at the forces the way we normally do. So if we're looking at the forces on P, we can say the force is mass times acceleration, so that's going to be force is 8a in general. The other way we can look at that force is we can say that it's going up, so it's going to be 2t minus 8g. That's the other way we can see what the forces are. We can equate those forces. So 8a is equal to 2t minus 8g, and I can rearrange that, and I get 8g plus 8a is equal to 2t, divide across by 2, and I get 4g plus 4a is equal to t. It's my first one. Let's look at Q. So in Q, I know that the force is mass times acceleration. So the mass is 6 and the acceleration this time is 2a. Because remember, we're getting that from here. Okay? So that means that the force is 12a. The other way that we can write the force is, remember the dominant, it's going down this time. So we have 6g minus t. So I can say 12a is equal to 6g minus t. Or I can say that 6g minus 12a is equal to. Then we can equate these. Okay, and if we equate the two, what we get is that 4g plus 4a equals t, and t is equal to 6g minus 12a. So I can say 4g plus 4a is equal to 6g minus 12a. I can bring all the a's over to the left and all the g's over to the right, and I get that 16a is equal to 2g, so a is equal to 1 over 8g. Okay, now, for now I'd like you to have a look at exercise 5D, questions 1 to 4. They should be pretty similar to what we've done here. Let me know any issues and if you want me to put up the solutions.